So here's the title from this particular lesson, cube root functions. So you could always pause this video if I go too fast. So let me move along here. And these are the things that you need to know. So let me just say a few things here as you guys copy this down. So cube root functions, this is the only equation we'll be using for cube root functions, and HK is the inflection point. Now let me hold up a couple of pieces of paper over these blank spots, and you can take a screenshot if you want. So if A is positive, then your graph is going to look like something like this. And if A is negative, like that, if A is negative, like negative A, you'll have negative orientation, which will be something like that. So if you want, you can screenshot. Let me just put them, I guess, a little bit closer to the screen. So for positive A versus negative A, this is what we have. So you could screenshot that if you want. And then the bottom sentence here, it says the domain and range for all cube root functions is, of course, there you are, all real numbers. So there you have it. And again, you could always pause it if I'm going too fast. Let me move along here. And let me say this, why don't you guys copy this down right there. And here we have the end behavior. So last time we discussed the end behavior very informally. Here in this lesson, we'll establish how to communicate the idea of end behavior very formally. So that's a definition. And why don't you guys copy this down here? Put that down there. And I'll show you guys how to make these translations. So let me show you guys how to make some translations. So when we're talking about end behavior, we don't really use the words up, down, left, and right. Instead, we say the following. Instead of saying right, you're gonna say X approaches infinity. Instead of saying left, you say X approaches negative infinity. Instead of saying up, you say f of X approaches infinity. And instead of saying down, you say f of X approaches negative infinity. And let me explain to you why. So I'll use it here in green, I suppose. So you don't have to write the stuff in green. Let me just make a comment here. You know how the x-axis goes like that and like that? And remember that y, it can be written formally as f of X. And then check this out. As you go to the right, x's get bigger. And that's why as you go to the right, x's get bigger, like infinity big. As you go to the left, the x's get bigger in the negative direction, so like smaller. And that's why as you go left, you say this instead. How about going up? As you go up, your y coordinate or your f of x's, right here, they get bigger, so that's why it's infinity. So this is how you translate. Up, down, left, right. So with that in mind, let's go back to the notes. Why don't we try this problem here so you guys can copy this down as you see it. And why don't you just pause the video now if you want to write all this down, because in a couple of seconds, I will begin the process. 3, 2, 1. So the first thing that you want to do is you want to find HK. So set the inside of the radical equal to 0, solve, and the number that you get, that is H. So negative 2 is H, you put that in the middle of your table. The number chilling in the back, that's always gonna be your K value, goes right there. Then do what you've been doing before. Pick numbers before and after negative 2. Spread the numbers out if you want. I'll just be random. I'll just go before negative 2 and after negative 2. I suppose something like this is decent. Now, the hardest part of today's lesson, as I was telling my students, is knowing how to use your Casios. So it's a good thing I have a little camera here, right? I can show you what I type in. So for instance, let's take negative 7 and plug it in here because I need this column. I need these points, which I can plot here, and I'm done. So negative 7 goes in for X there. So let me just leave this like this here. I think you can see it there. Let me focus the camera just to make sure. That looks pretty good. So let me type all of this in. So first of all, I need a negative. Here's my negative. And then I need a fraction right there. And then I need a fifth root. So what I'm gonna do is I'm gonna hit shift. Then I'm gonna hit this button here like that. So it's a fifth root. 8, 7, 6, 5, 4, 3, 2, 1. And now I need to go down to the denominator. You see how the 8 is not inside of the radical symbol. It is independent of it. So there's an 8 there. Multiplication. Now I need a cubic root. So like that, right? Shift, boom. And then 3, then go inside. I'm plugging in negative 7 in for X. So it'll be negative 7 plus 2. And then the -1 is outside. So go outside, then go -1, hit enter. And that is this one here. So it's about 7.3, let's call it. And then what's cool about the Casio is I can go back and I can change the -7 into a -4. So I just type in a 4 and I get this number here. So let me do the rest of these just to save you guys some time. So these are the points that I get, and let me plot them real quickly here. So -2, -1. I scaled my graph by 2, so you don't have to do that. So that's my inflection point. I'll leave that in orange. I'll do everyone else here in black. So -7, about 7.3, it's like right there. -4, 5.1 is like right here. And then 0, -7.1 is like right there. Make that look a little bolder. And then 4, -9.8, that's like down here somewhere. And recall that this section is on cube roots. And cube root functions, they look like, where's that little piece of paper at? They look like this if A is positive, and they look like this if A is negative. So the cube roots should look like this. Last week was cubics. Cubics look like that. But this week, cube roots look like this. So let me connect these points accordingly. Something like that. Not too bad. There it is. So that's the graph, which was dependent on this table. As for end behavior, which is what they asked for, well, look at the graph here. It's going to be left up, right? Because as you go left, the graph is moving up. And as you go to the right, the graph is going down. So it's left up. So tell them as, and then how do you say left? That's left, right? As left, comma. The graph, which is called g of x, let me hold this like that. The graph is called g of x. The graph goes, so left is up, right? Because left up, like that. So always tell the teacher what happens when you go left. And then after that, tells me what happens as you go to the right. So as, that means right. And as you move to the right, the graph goes down. And the graph is called g of x. So there you have it. Inflection point, HK, table with weird numbers, knowing how to use your Casios. Also, if you don't have a Casio, I'll show you how to do that on Desmos in just a moment. So table, points, and the graph helps us with end behavior. And now here is the other problem from today's lesson. And let me just explain what we're going to do, and then we will actually do it. So the point or the goal here is to state the coordinates of the shoes. The shoes are these custom Air Force One, which I plan on creating for my baby niece for her first birthday. So let me zoom out here. And the goal is to find the coordinates of the shoes, the inflection point right there. And we have one coordinate, we just have to find the other. So really the goal is to find K. So write all that down, and then we can dive deep into the problem in 3, 2, 1. So for this last problem here, the one with the shoes, I would recommend that you guys write down the equation that we have for cube cube root. And we know that the inflection point was at -2k. So we can plug that in for h, and I guess it stays k. So we have y equals a cubic root x minus -2 plus k. You guys know that the double negative becomes positive like that. And then we had a couple of other points to play with. Remember that? If you look at the picture that you wrote down, one of the points was 6 comma 2 square root 7 plus 4. And the other one was 25, that's a 25, comma 3 square root 7 plus 4. So here's what I intend to do. I'm going to plug that in for x, and I'm going to plug all of that in for y. You see, my goal is to find K, right? Because the shoes are located here. That's the shoes. That's the little baby custom Air Force Ones. So really the goal is to find K because it's part of the shoes. So I need K. So I'm going to take these points and plug them into this equation, and you guys will see what happens. So plug 6 in for x here and plug all that gibberish in for y there. So we get 2 square root 7 plus 4 equals a cubic root 6 plus 2 plus k. And you know what? I'm going to do the exact same thing for the other point. And I'm going to plug this into the same equation. So I'm going to get something here underneath it. which kind of looks the same, but it came from a completely different person, right? It came from a different equation. And what I'm gonna do is I'm gonna bracket this because I have a system of equations. And my goal is K. I need to know what K is. So look for opportunities to make this simpler. For instance, you see 6 plus 2, you see 25 plus 2. You guys know what that is. That's just 8 plus K. And this stays the same here, like that. A cubic root of 27 plus K. Keep these braced together. And then, you know what? These numbers here in green, I know what that is. I know what that is. The cubic root of 8 is 2, and the cubic root of 27 is just 3. Let me focus my camera. So this is 2 square root 7 plus 4 equals 2a plus k. And similarly, I have this here, 3a plus k. Keep these braced together. And now what we need to do is we need to remember last year in IM2, there is a method that they called elimination, if I remember how to spell, elimination. And that's when you have two variables, a and k. But I don't want a, I want k, because k is the goal, right? Excusez-moi. K is the goal. I want k, I don't want a, I want a to be gone. So here's what I'm gonna do. I'm looking at a. I see that this is 2a and I see that this is 3a. And when I see 2 and 3, I think of the number 6. I'm gonna turn this into 6 and I'm gonna turn this into negative 6 because 6 and negative 6, whoosh, they knock out. So I'm gonna multiply the top equation by 3 and the bottom equation by negative 2 because I can look into the future and I can see that that's gonna be 6a and that's gonna be negative 6a. And then the a's are gone. And then I'm left only with k's, which is what I want because it's part of the shoes. So now what I have to do is take this 3 and distribute. Take negative 2, distribute. And let's see what we get in return. Let me just slide this down like that. Let me get this one here. So if I distribute the top equation, it should say 6 square root 7 plus 12 equals 6a plus 3k. The bottom equation, something like this, something like that. I suppose you could keep them braced together if you want, but we've worked hard to reach this point because now, let me move it up a little bit. What happens with the a's? Gone. And, oh, this is nice. Those also go away. That did not have to happen, but it did, and I'm not mad. This did have to go away, which is why you chose those numbers strategically. And by the way, you could have switched these, right? You could have switched those. It wouldn't have mattered. So let's finish this together, guys. 12 minus 8 is 4. 3k minus 2k is 1k. Divide by 1 doesn't change anything. K is 4. And that's the y coordinate of the shoes. Remember that? The shoes were at negative 2k if you guys look at your notes that you copied down. So finish the problem. You can say the shoes are at, so always make sure that you answer the question. They wanted to know the coordinates of the shoes, and the coordinates of the shoes are this. And I believe K is 4 because if you look at your picture, the shoes were above the x-axis. Let me hold it like that so you can actually see it. The shoes were above the x-axis, which means that the y coordinate K should be positive, which this is. So final answer, the last thing that I owe you is to show you how to type something like this into Desmos. So let me bring my camera back to my computer. So if I go back to Desmos here, I don't really have to type in the exact same thing. That doesn't really matter. I'm just gonna type in something crazy to show you how this works on Desmos. So what you wanna do here on Desmos is you wanna go to the screen, you wanna go to functions, and you wanna go to miscellaneous. And then you wanna click on the nth root. You see how that does that? Now it lets you type in some stuff. So for instance, if I want a 7th root, I type in a 7th root. If I want to go like 1, 2, 3, 4, whatever, that's how you do it. If you want to go in the bottom, you go outside. See how it's outside? Then hit division or like a slash and boom, you can just type in whatever. Then you can go off to the side and you can go shift 8 or just multiplication, right? Multiplication, same thing. And then you can do whatever you want there. Functions, miscellaneous. Let me make this smaller. not that small e. Control Z, come back. There it is. So let me zoom in a little bit more. So I go to functions, miscellaneous, click that one there, and then just type in whatever you have to type in, 3 if you want, and like 7 minus 12, whatever. So the point is, if you don't have a Casio, you can always go to Desmos because it lets you do it just like that. So the key was the menu, functions, miscellaneous, boom, nth root. So I hope that helped, guys. Keep working hard, and I'll talk to you guys next time.